第41集，看着时间走过。
萌萌 ，What are you looking at?
哦，你好，克里斯博士。我在想用什么办法能把水中散开的食用色素变回到原来的那一小滴的样子？你觉得有可能吗
？It's certainly possible, but it would be very surprising. You might have to wait your entire life to see that. Here, watch this. Is this what you're looking for? What does that look like, Meng Meng?
哇，好神奇，看起来就像时间倒退了似的。
Exactly right. Now, let's watch it properly.
这样看起来舒服多了，前面那个片段看起来真奇怪。
Yes. This is the movement of food coloring in water. Do you know how the food coloring spreads in water? Let's think about zooming in and looking at the atoms. Here, we have zoomed in on a bowl of atoms. Do you see the food coloring atoms moving and bouncing off the water atoms?
我看到了，水就是这么变成红色的吗？
Yes. And now let's zoom in, but look at the situation in reverse. Can you tell the difference between this situation and the previous situation?
我看看，看起来完全一样。
Yes, they're truly the same. But looking at the atoms, can you tell whether time is moving forward or backward?
是啊，我根本看不出来。
Correct. In all our laws of physics, the rules work the same whether time is moving forward or backward. We say that the laws are reversible.
规律是可逆的，什么意思呀？
It means that whether or not time is moving forward or backward, the laws of physics, such as Newton's laws of motion that we learned before, work the same way.
但这怎么可能呢？时间始终都是向前推移的。我们有昨天、今天，然后很快就会到明天了。你说的时间倒流怎么会发生呢？
This stumps scientists even today. Have a look. Time is always moving forward. And as Meng Meng said, we never see a situation where time moves backwards. But if we can move backwards, why can't time? Children, would you like to know why time only moves in one direction? Come with me and I'll show you. Hi children, do you remember last time when I asked you to draw some pictures of entropy changing? Entropy can go from low to high, or high to low, or it might just stay the same.
从低变高，那是热力学第二定律，就像是我的房间能从干净变得乱糟糟的一样。还有冰融化成水。
Good memory, Meng Meng. And high to low, what about that?
对，我们可以利用能量来做到。我们的冰箱就用电能将液体水变成冰。还有我用自己的力量把房间打扫干净。
Very good. And entropy can stay the same. For example, when your room is as messy as possible, it can't get any messier. The toys can move around, but it's still the same mess, and the entropy stays the same.
那就是糟到不能再糟的情况了。你能给我们展示一张你画的画吗，克里斯博士？
Oh, right. Thank you for reminding me. Here is my first picture. What do you think? Which one has higher entropy?
这个简单，打碎了的鸡蛋拥有的伤更高，因为它脏兮兮的呀。
Right. And which situation came first?
你问的问题都太简单了，克里斯博士。完整的蛋是先发生的，已经打破的鸡蛋是没法恢复原状的呀。
That's right, Meng Meng. But how about this one?
这2个鸡蛋都没被打碎，它们看起来一样啊。
These aren't eggs. These are balls. What do you think is being shown here?
这些是球，你画的是你在扔一颗红色的球吗？左边那个是先发生的，是刚刚扔的时候；右边那个是后发生的，因为球看上去比左边的高。
Maybe. But what if I told you this is a picture of me catching a ball? Look.
等一下，我看出来了，这个球在往下掉，所以现在右边的球更高，是先发生的；左边的球更低，是后发生的，正好反过来了。
Yes, this is an example of the reversible laws of physics. We can't tell which situation came first. Whereas in the egg drawing, we can easily tell which situation came first. We can't reverse this situation. Meng Meng, can you think of some more examples showing the reversible laws of physics?
我明白了，如果我把房间分2次画出来，别人很难分出我的房间到底是在变得更乱，还是在变得更整洁，先后顺序就区分不出来，对吗？
That's correct, Meng Meng. Children, were you able to draw a situation that could stump Mom and Dad, showing the reversible laws of physics? Children, it's hard for us to judge time if we're only looking at the appearance of the physics rules applied to single things. Do you remember the video we saw earlier of the food coloring atoms bouncing around in the water? We couldn't tell whether the movie was being played forward or backward.
我记得在那2个情况下，水原子和食用色素原子都是互相撞来撞去的。
That's right. The physics rules allow the food coloring atoms to bounce every which way. By only looking at the food coloring atoms, it's impossible to tell whether the food coloring is spreading or gathering together.
是的，我发现越是放大了看，越是看不出来怎么回事，而越是从远处看，越是能知道食用色素在怎么运动。
Right. In other words, there's no difference between spreading or gathering for a single atom. But there is a difference when we take a lot of atoms and add them up together and they move all at once. That is to say, when we zoom out so that we can no longer see the atoms, we can clearly see the colors spreading rather than gathering.
这真是一个很奇怪的现象，感觉好像是每一个原子都很爱干净，但是当所有的原子都加在一起，就变得越来越乱了。
That's a vivid demonstration.
那到底有没有可能发生食用色素聚集回一起的情况呢？这又是怎么发生的呢？如果物理定律可行的话，我们怎么看不到食用色素弹回来的场景呢？
Well, scientists asked this question a long time ago, and the answer they came up with was entropy and a special rule.
我知道，就是事情都会越来越乱，越来越糟，这是热力学第2定律。
Great job, Meng Meng. The second law of thermodynamics says that entropy always increases. The atoms don't prefer to go in any direction, but entropy does. It goes up.
熵会增加，就意味着事物会从整齐变得糟乱。可是这是为什么呢？这太令人沮丧了。要是能反过来，不是更好吗？
That requires hard work. We've not discovered a situation where entropy decreases on its own.
我有一个好主意，克里斯博士。如果有一种魔力能把时间定住，停止流动，那我们就可以阻止熵的变化了，是不是？
That's an adorable idea, Meng Meng. But we all know we can't stop the flow of time.
我想也是。妈妈说，人们只能和时间赛跑，但没有人能管住时间。但是我想知道，时间是从哪儿来的呢？
Good question, Meng Meng. Come to the lab with me, and I'll show you what time is and its direction. Children, Meng Meng asked, what is time? Time is a way to order events. Let me draw 3 things. Here I have an ice cube, a puddle of water, and an ice cube that's half melted. Time is just the way in which we order these things. We know that ice will eventually turn to water. So we know that this event came first, followed by this event, and finally this event. If we draw the direction, we get an arrow, the arrow of time.
哦，我明白了。所以说，熵在追随着时间的方向吗？
That's right. The second law of thermodynamics says that entropy increases. So we have entropy small, medium, and large. So we know that time is going in this direction, the direction of increasing entropy.
我明白了。所以说，温度也会在时间指向的方向那里聚集到一起吗？
Good question, Meng Meng. Here we have 2 cups at different temperatures. The ice, we know, is very cold, and the water is warm. And if we put these 2 together, then eventually they will both be the same temperature. And we know this is true because this situation is low entropy, and the situation where they're both at the same temperature is high entropy.
我明白了。可是等等，如果熵一直都在增加，那它永远都停不下来吗？
Wow, that's a very insightful question. I'm glad.
等等，如果我们让时光倒流了，那熵就会减少。如果时间倒流了的话，降低了的熵是不是永远都不会增加了呢？时间有始点，有终点吗？
Wow, these are some very big questions. But I think we've had enough for today. Why don't we play some games and we can tackle these questions next time?
这个主意不错，克里斯博士。我想这些大问题想得头都疼了。亲子游戏。
Hi children. Today we learned about the arrow of time. The second law of thermodynamics says that entropy goes from low to high, and this tells us the direction of time. This leads to many big questions. Did time have a beginning? Does it have an end? Why don't we build our own little universe and find out? Here I have all the ingredients for a universe. I have a dish of water. That will be space. Have some soap bubbles. Those will be our planets. Some food coloring can be our stars. Some sugar will be the many comets that are floating around. There are cold places in the universe. And there are hot places in the universe. And we've set all of these things in motion, and we're going to find out what will happen. Why don't you build your own universe at home and see what happens to it? And we'll find out next time what this tells us about the beginning and end of time. See you then.